In this video, we're going to go through the 5 guidelines that you can use to write out Lewis structures. And this is for like what it's called normal Lewis structures, where you don't have exceptions to the octet rule and things like that. So if you're given a molecule and asked to write the Lewis structure for it, say we have the molecule NH3. And the question, and you're asked, what's the Lewis structure for this molecule? So step 1 is to determine the number of valence electrons. Lewis structures are all about valence electrons, so we want to know how many there are total in our molecule. So let's look at this molecule, for example. So nitrogen, if we go to our the periodic table, we can see it's 5 columns over from the left in the periodic table. This has 5 valence electrons. Hydrogen has 1 valence electron, so we're going to have 3 times 1 electron. So our total number of valence electrons is 8 in ammonia. Okay, that's step 1 done. Now, one thing to keep track of, say we were looking at ammonium instead, NH4+. We need to remember that this is an ion and has lost an electron. So we would count up our 5 electrons here, and there's 4 times 1 electron, so each hydrogen contributes 1 electron, but we have to subtract 1 electron due to the fact that this is a positive ion. And so we would still get actually the same number of electrons in ammonium as we have in ammonia. So the total number of electrons is also 8. And if we have an anion, say something like carbonate, CO3 2-, we would need to keep track that there are 2 extra electrons in this molecule, or molecular ion, I should say. So carbon has 4 valence electrons if you check the periodic table, and I encourage you, if you're not sure that it has 4, go look at the periodic table and double check. Each oxygen will have 6, so we have 3 times 6 electrons in this example, and then an extra 2 electrons due to the charge on the ion here. So 3 times 6 is 18. 18 plus 4 is 22, and so our total number of valence electrons in this example is 24 electrons. Okay, so this is just a few examples of going through and determining the number of valence electrons. Step 2 is to arrange symbols for the atoms to show how they're bonded. And then the first step would just be, if it's a covalent molecule, it's a molecular compound, there's at least a single bond between all the different atoms. So you want to then add single bonds. If you're not sure like how the atoms should be arranged, don't worry, we'll talk about how to do that. But that's partially it comes with practice and just getting used to like what you would expect, and partially there are some guidelines we can follow for that. So in these examples, these first 2, it's pretty straightforward, and even our last one. One of the guidelines we can follow is usually the atom in the middle is the one that's listed first. So that's true for all these. And you can't really ever have hydrogen in the middle because it only forms 1 bond with anything. So if I give myself some more space here, in our examples here, we can put nitrogen is going to be in the middle, and it's going to have 3 hydrogens around it, and we'll draw a single bond to each of those. NH4+, well, there will be 4 bonds because we have 4 hydrogens. And then carbonate, we'll put carbon in the middle with 3 oxygens around it, and we'll make single bonds between all of those. Okay, so that's step 2. Let's go on to step 3. So once we have determined the number of valence electrons, written the basic outline of the molecule, written each of the symbols with at least a single bond between them, step 3 is to complete the octets of the non-central atoms. Most of the molecules we'll be looking at here have a central atom with things bonded to it, and so first complete the octets of the things around the central atom. In our examples above, looking at nitrogen, ammonia, we had here. We're actually already done at this point because our non-central atoms are all hydrogen. Again, hydrogen has the duet rule instead of the octet rule. So, wherever it says octet, hydrogen is always going to be an exception here. They already have enough electrons. Let's look at the carbonate instead. That's a more interesting case. We need to add enough electrons to complete the octets. Okay, so for all of our oxygens need 6 more electrons because they have 2 electrons from sharing with the carbon. All right, so that's what completing the octet looks like. All right, step 4. Compare the number of valence electrons in the Lewis structure at this point to the total from step 1. So compare the number of valence electrons in the structure with the total from step 1. All right. If those numbers are the same, you're done, right? But if there's unused valence electrons, you're going to need to find a place to put them. If there are extra electrons, put them on the central atom. Okay, let's look at our examples here. So ammonia, if we go back up above, had a total of 8 valence electrons. We've added 2, let me use a different color, 2 electrons here, 2 electrons here, 2 electrons here. That's a total of 6 electrons, so we'll add our last 2 electrons to the nitrogen. All right, so now we have the correct number of electrons. Coming back to the carbonate, if we go back up, I believe our total was 24. Yes, 24 electrons. All right, and let's count the number of electrons that we have here. So 2, 4, 6, I shouldn't write dots, that's confusing. But 2, 4, 6, maybe I'll do it with the mouse. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we have the correct number of valence electrons. So we don't need to add any more electrons to the structure. We're not quite done yet because carbon doesn't have a complete octet. And that's where we're going to get to step number 5, our final one. Our final step is to complete the octet on the central atom. Now, how do we do this? If there's already an octet, you're done. But if there's not an octet, if there's less than an octet, you need to create additional bonds. So meaning some of your electrons on your other atoms will need to be shared with the central atom. So create additional bonds if needed. So coming back up to our examples that we have up here, with ammonia, NH3, we're good because we've got our 6 shared electrons and then our 2 extra ones we added, and the octet is complete on the nitrogen. So this one is check, it's done. But if we come over to our carbonate, we have the correct number of electrons. We already have 24 electrons. But if we look at the carbon, it only has 6 electrons around it, the 3 shared pairs of electrons. So carbon needs 1 more bond. And so what we'll do is we'll pick one of the oxygens. At this point, it doesn't matter which oxygen. And we will share those electrons in a bond so that oxygen still has its octet, but now carbon will also have its octet. So the way I would do this is I would just erase these electrons and draw an additional bond here. And now we are done. All of our atoms have octets, and we have the structure of the molecule. Now, you may be wondering, well, why did I pick the oxygen in the upper left corner to share the electrons? It could have been either of the other oxygens. We'll get to this later in the chapter, but for right now, just pick one at random, basically. And so that is the basic idea of how to write a Lewis structure. We'll do some more examples in the next video.